Tonight's speaker is Hayden Frank. He is a senior meteorologist with the National Weather Service. He graduated from Pennsylvania State University in 1998 with a bachelor's degree in meteorology, and he's been at the Boston office at the National Weather Service since 2003. Thank you for being here, Hayden. Take it away.
Yeah, no, thank you for having me here, Rosie. And yeah, we have a small group tonight, so feel free to, if you have any questions as we go along, don't hesitate to ask. I'll give you a little background on myself. I started in the Weather Service in Wichita, Kansas, actually briefly in Tulsa, then Wichita, where I got into storm chasing, severe weather, that aspect of meteorology, which is always very, very fascinating. And from there, I ended up going to the Boston office. So in the Boston office, we kind of get a bit of everything. We get severe weather, obviously not like the Midwest, fortunately. But our big focus is obviously winter storms, snowstorms, tropical systems. We get those occasionally. We're long overdue for a landfalling hurricane, unfortunately. It's been, the last one was Bob in the early 90s. So we're way overdue for that. So I really kind of wanted to orient something towards, safety, a little more about what we do. And again, as we go along, feel free to ask any questions. So weather, a lot of what we do is behind the scenes. We will do interviews with television, newspaper, radio stations, especially when there's winter storms. They'll call and ask for different information. But a lot of what our job is diagnosing the weather models and doing that behind the scenes. So obviously on the upper right there, you can see a map of the United States, and everything's kind of broken down into weird blocks, and that's actually represents an office, weather office. So there's 122 local forecast offices. So we're one of 122. We're located in the Norton area in southeast Massachusetts. The New York City office is actually located out on Long Island. Then to our west is the Albany office. And then to our north is the Portland office, which is in Gray, Maine. So this is our area of responsibility. You can see in the lower right here. So we've got all of Massachusetts except Berkshire County. Albany does that. Then we have the 3 northern Connecticut counties, and we have all of Rhode Island, and we also have the outer islands. So during like a winter storm, it's not unusual that, say, Nantucket could be 57 degrees with heavy rain, coastal flooding, and winds gusting near hurricane force. And then you get back towards Worcester, and they're dealing with heavy snow, and temperatures are in the 20s and near blizzard conditions. So it's quite the variety of weather that we experience here. So a little bit about the Weather Service in general. So we have 26 employees. That includes meteorologists. I'm one of those, obviously. We have electronic technicians. Anytime there's equipment goes out, it needs to be repaired, we'll call one of those folks in and they'll do it. Also, they maintain our radar, making sure that's operating. And obviously, we have an administrative support staff as well. The thing about our job that's different than a lot of jobs is it's obviously weather. It doesn't go to sleep. So it's a 24/7, 365 days a year job. So there's always at least 2 people, 2 forecasters working in the office. So a few weeks ago, I worked my 7 stretch of overnight shifts. We kind of rotate through a schedule. So like most forecasters, they'll end up working 7 overnight shifts in, say, a 35-day period, somewhere in there. So obviously most people prefer the day shifts, but we have to obviously be staffed 24/7. So observations, forecasts out 7 days. All watches and warnings are issued by the National Weather Service. So anytime you hear of a high wind watch or winter storm watch or tornado warning, or that all comes from the Weather Service. And our main mission is protection of life and property. So this is a map of the number of tornadoes that we average, per state from 1992 through 2021. So this is about a 30-year normal, and you can see the Central Plains, takes the cake on that one. But what you'll notice is tornadoes happen everywhere in the country, including Alaska. Obviously, much more rare. But we end up with a few a year here in New England. So this is actually a cumulative amount of the tornadoes that have been observed, and this goes back into the early 50s. So obviously Worcester County, it's divided by county, so that's why that number is the highest. But you'll also see that the western and central areas of Massachusetts and obviously the interior portions of Connecticut tend to get more tornadoes than areas near the coast. Anyone wonder why that might occur? Well, the cool ocean, it usually kills thunderstorms. Not always, but it tends to kind of keep them from being as intense as when you get further inland, because it's usually warmer. But it doesn't always work that way. There's exceptions to that. So when we looked through last year, this kind of was a representative of what we often have. We actually had 12 tornadoes last year. A lot were in August during a morning event. We had ones going through Providence, Rhode Island area, which, obviously that's more unusual on the coast, a couple in Connecticut, and 7 in Massachusetts. But what I want everyone to notice is wind. That's our primary damage producer in southern New England. A lot of times and the thing with wind when you get thunderstorms is it can be over a long area, a long swath. Tornadoes tend to be more localized and obviously more intense in some cases, not all. But wind damage can be very extensive with thunderstorms. So if you wanted to make note of some weather sites, weather.gov/Boston, that's us. And our website's pretty user-friendly, so we can kind of go over that if you want. And then the Storm Prediction Center, spc.noaa.gov, they give the convective, as they call it, thunderstorm outlooks for the next 7 days, where they're expecting just general thunder, where there's a potential for severe weather. They have different categories. And then there's a lot of, planning sites. We always tell people, prepare ahead of time for severe weather. Don't wait till the last minute, till the storm's bearing down. So there's a lot of information on ready.gov, and then you could go to mass.gov too. That takes you to the Massachusetts Emergency Management Agency, and they have a lot of information there, because everyone's risk can vary depending on where they are. So if you're on the coast, your house is on the coast, obviously you're going to be prone to coastal flooding. Whereas, if you're, say, further inland, you may be more prone to snow, ice events. But they do tailor that to specific areas based on what most often occurs. So, ingredients to a thunderstorm. This is just some basic information on meteorology, how they develop. So obviously you need moisture, right? It's going to rain, you're going to need moisture. So given our proximity to the ocean, that's not a problem here. Obviously you can get it off the Atlantic, you can get it from the Gulf, and then you can obviously get Pacific moisture streaming all the way across the country. But in addition to the moisture, you usually need some type of forcing mechanism. That can be a cold front, it can be a warm front. Well, if you think of cold air versus warm air, if you heat your house, warm air is less dense than cold air, so the warm air tends to rise. So it obviously gets warmer as you get up into second floor if you have a house, or even into the attic. But the cold air tends to be more dense, so it tends to be lower. So that's kind of how you kind of visualize that. As that cold, dense air undercuts the warm air, it forces it up. And if conditions are right, if you have enough moisture, you get clouds, rain, thunderstorms, and potentially severe weather. So usually there's two cases on the bottom there. So we'll start on the one on the right, what we call a stable air mass. That's where you have cool air at the surface and warm air above. That's usually not conducive for thunderstorms, but you do still get them because they can be elevated, they can be generated in this area, and then you have warm air here, but you have cooler air here. But they're most prevalent when you're warm on the ground and going up, you're cooling off really quickly, because that allows those clouds to rise, cool, condense into thunderstorms. So terrain, believe it or not, obviously we don't have huge mountains, but the Worcester Hills, the Berkshires, getting 1,000 to 1,500 feet in spots. That lift can actually aid in the production of showers, thunderstorms, and things of that nature, depending on what the wind direction is. So like the Worcester Hills, if the wind's blowing east, there's going to be a subtle upslope, as we call it. That allows the air to rise, so you can get like localized heavier rain or snow amounts in that area. So different thunderstorm stages. This is just some basic stuff. So if it's the afternoon and you're working, you look outside, you start to see these puffy clouds developing. Well, what's happening is you're heating the ground, that air's rising, it's cooling and it's condensing into clouds. Now, if you have the conditions are right, where you have a front coming in, that really gets the lift up going, right? So now you really force the clouds up to, say, 40, 50,000 feet in the air. That's where you could get big, big thunderstorms. And then you get the showers, you get the thunderstorms, and then the dissipation is when you get that cold outflow. So that's generally how it works. That's why you tend to see in the morning, again, not always, but it's more clear. And then as you get in the afternoon, you'll see those puffy clouds. Normally, like a day like today, we got those clouds, but there wasn't enough moisture, and there wasn't enough of a front in the area to really trigger anything. So this is kind of a schematic diagram of what a thunderstorm would look like. This would be a big supercell thunderstorm, as we call them, and I'll explain that in a bit. But so you get your warm air, your moisture inflowing into that area. You get what we call an updraft. That's that air lifting up, and something called an overshooting top. You can see that sometimes in a distant thunderstorm. That's a really good indication of a very strong thunderstorm, because what happens is as air rises, it cools, but once it hits the tropopause And that's an area of the atmosphere, say above 11 kilometers, where we start to actually warm again instead of we're cooling as we lift, and then we get warmer. So the air can't rise past there. It's kind of like chimney smoke. In the morning, it'll kind of go to the side because there's that, what we call an inversion, and that means it's cold down on the ground and it's warmer above. But the thunderstorm updraft is so strong that it actually breaks through at the center of it. So that's where you know the core of the updraft, and you know you have a really strong storm. And then you get the cool downdraft air. This is where your all rain, wind, and hail is. And then obviously, if you did have a tornado, it's often on this part of the storm, the western part of the storm. So any questions on anything so far? Yeah, don't hesitate if you do. So depending on the type of weather pattern we're in, that's going to determine the exact form of the thunderstorms. So won't go into too much detail on this, but a single cell, it's usually just like an isolated storm, and the environment, the winds aloft are relatively weak. So what happens is it usually collapses on top of it. The downdraft collapses on the updraft and kills it. But as you get out into the multi-cell, multi-line, supercell, what happens is the wind fields are actually strong as you work up through the atmosphere. They could be 50, 60 knots, say at 20,000 feet. So what that allows is a separation of the updraft, downdrafts, so they don't cancel each other out, and you can, maintain strong thunderstorms, severe weather, and potentially significant severe weather. So yeah, these are single cell. Again, they're short-lived. They can be briefly severe, but the updraft usually, see the updraft, downdraft, they're very close to each other, so they kind of cancel each other out, and then the storm collapses. So this would be a more significant event. Obviously, this is a line of thunderstorms. You would actually see on our radar, it's a solid red line. And whenever you see that, you have a strong front coming through. You're not going to just get that during a warm and humid day. You really need a lot of what we call forcing to generate that. Yeah?
What does red, green, and yellow stand for?
Yeah, so it's just a color curve, but the darker returns, like the red, that's where the heaviest rain.
Rain density.
Yeah, rain intensity. And it's usually, what you'll also notice is usually the leading edge. And that's, when you see something like that, a linear structure, the big thing you're going to expect is strong, damaging winds. That's what's going to hit you first. And then, obviously, a period of torrential rain, maybe some hail. But usually, there's a saying that they used to say out in the plains, worst is first, then comes the rain. Because you're hit with the wind, sometimes it could be 50, 60, 70 mile an hour gust. And then, you have a torrential rain for like 30 to 45 minutes, depending on how quickly it's moving. But one thing you'll often notice is a shelf cloud. And it's sloping all the way across the sky. And when you see that, that's an indication of strong to damaging winds. Because you have that cool air from the thunderstorm rushing outward. And again, this was an event we had in May of 2020. And those are the most common severe weather events in New England. It's the straight line damaging winds. Yeah.
What causes them to choose direction? I mean, how do they move?
The thunderstorms? Yeah, so they're directed by what we call the upper level winds. So 20, 30, 40,000 feet, you know, where airplanes are flying. Depending on the wind direction at that level and the speed will often determine how quickly the storms are moving, whether going from north to south or west to east. Now prevailing, it's usually west, there's usually west to east trajectory because prevailing winds aloft at our latitude are usually from the west. So usually you'll see stuff coming in from, you know, if Worcester's getting hammered, then, you know, Quincy might be 45 minutes later, something in that nature, if that makes sense.
Another thing that happened a couple of times this year was there'd be thunderstorms like at Fenway Park, and we would have nothing. Or my neighbor who lives in another part of Quincy was having thunderstorms, and we had nothing.
Yeah, that's what's different about thunderstorms and a lot of what we get in the winter time. So, you know, in the winter, you may get a storm comes up. It brings like 8 to 12 hours of heavy rain, heavy snow, depending on the temperature. And there's not a huge difference unless you're crossing the rain-snow line. You know, people tend to get similar amounts. Now, thunderstorms, you can have a situation that is showed on the radar where everyone gets hit. But when you don't have a strong cold front, but it's very warm and humid, you can get isolated storms to pop up. And sometimes they don't move because there's no wind aloft to move them. So you get a thunderstorm developing, you know, 5 miles from here. It just sits there, jumps 3 inches of rain. You know, streets are flooding. And here it's partly sunny. So that's part of it. And that can be difficult to kind of communicate to people, especially like during the spring and summer. A lot of times, you know, the forecast may say chance of showers and thunderstorms each day, Wednesday, Thursday, Friday. But usually they're scattered, hit and miss, and they don't last that long in most locations. So whereas in the wintertime, you tend to get, you know, you could have a day of rain or snow. You usually don't have that with thunderstorms. So, but here, this is a good vantage point because you see that cool, this is that cool outflow from the thunderstorm, you know, rushing eastward, and it's undercutting because the cold air is more dense. So that's why you get that, what we call a shelf cloud look. There's a really good example, like from horizon to horizon. You know, when you see that, you're going to be thinking damaging winds. Okay, well, I'll give you a little tutorial of our website here. So if you just do a weather.gov, you get a map of the United States, and you can kind of click on the portion of the forecast, the area that you're interested in. So what you can do, there's a couple ways to do it. You can type, you know, Quincy right in here, or you can, you know, click right on the map here, and what you'll get is a 7-day forecast there. And if we do have any watches or warnings or headlines, they will appear up here. And the other thing you can also do is you can select the hourly weather forecast, where this will give you the temperatures, dew points, wind direction, and you could go forward. So we'll go forward 2 days, where you have, this is what the temperatures look like. So you'd see we're actually in a really warm pattern coming up here. Temperatures, we're looking at highs, upper 70s to low 80s, much of the time period. So, but you could select also a lot of different elements in here as well. Because for our forecasts, we, in addition to the public forecast, we do aviation forecasts. So we have 10 airports that we do. Obviously, Boston and Providence are pretty important because if the wind, even on a quiet weather day, they have to take off and land against the wind. So if the wind shifts, if like we get a sea breeze and the wind shifts to the east, they have to reroute all their planes. So we're usually talking to the airport tower about that. And we also have marine forecasting. That's also really big in our area because we've got a lot of recreational boaters, and we also have, fishermen off the coast. So we do forecasts so if you click out here, you actually get our wave height and wind forecast. So in this case, the weather's quiet, we have high pressure overhead. So you see seas like just not really much more than 1 to 2 feet. But, in a winter storm, you could get seas 20, 25, 30 feet. So it just depends on the intensity of the storm, the wind direction as well. But that's a look at there. And then if you want to know more details, what we do is we write a forecast discussion, and you can click that. And that kind of will run through not just the forecast, but our confidence levels, discuss uncertainties, and it's broken down into the near term, short term, long term, and then there's an aviation section where we tailor that for the various airports, and then a marine section, wind, waves, seas. There's a lot of things that impact the mariners. If you get really cold weather in January or February, temperatures get down into single digits and teens, you get something called freezing spray. And that's obviously that ocean spray coming up and freezing on the boat. And it's actually sank some boats. There was one in 2008 that sank off Hyannis as a result of freezing spray. So it is pretty dangerous. But that's look at our website, and it'll also link you to, like, we'll put usually a weather story. What's the primary weather going on? And I think in this case, we put the probability of precipitation because there's nothing through the weekend. We've got high pressure in control. So quiet, dry, and we're going to be warming up too. So this is the Weather Prediction Center. They kind of do a lot of forecasting nationally. So what they'll have is excessive rainfall, and that's where they're concerned about potential for flash flooding. So in this case, moderate. We do have a tropical system coming up here. They actually issued hurricane watches in this area. Usually when you get these type of tropical systems, one of the big threats is not just the wind, obviously the storm surge, but it's the torrential rain. When you get something slow moving, you can get 10, 20 inches of rain, and that just causes catastrophic flooding. But you can see this is the area they're really concerned about. If you ever see a high risk on there, which only comes out like a few times a year usually, that's really serious. They're very rarely issued, but on high risk days that accounts for most of flash flood fatalities and property damage. Yeah.
I just had a question. So it seems like all the big numbers on the rainfall are always down south. Like the winds can maintain all the way up to our area and beyond, right? But we never seem to get 10 to 20 or anything like that. So. does that lose velocity?
Yeah, so I mean, there are instances where you can get like 5, 10, 15 inches of rain. There are past occurrences of that in New England, but you're right in the sense that it's much more likely to happen down south, and it's much more likely to be, higher end, 25, 30. That's, for us, that'd be crazy. But one of the reasons is because as you get further south, you're more cut off from the jet stream, the wind's aloft, so storms tend to move slower. When they get up here, they tend to really accelerate. And when they accelerate, may get torrential rain, but instead of saying 24 to 48 hours, it may be in 6 to 12 hours, if that makes sense. But we can look at another thing, is the National Hurricane Center. So these are our national centers. So, we're all part of the same team. We're coordinating with each other. The national centers, obviously, they're doing a broad scale forecast for the entire area. And then, the local offices, they're issuing a lot of the specific warnings for their area, especially flash flood, tornado warnings in a scenario where you have a potential tropical system. But we can click on this, and this is the latest update on the Hurricane Francine. So initially it's a tropical storm that is expected to become a hurricane. That's why we had issued those hurricane watches across Louisiana, and this is the general expected track of it. You guys familiar with this website? Anyone ever look at it? But there's a lot of different things that emergency managers can look at. So we could go to like wind speed probabilities. So where you see in purple, there's the storm. There's the probability of tropical storm force winds. So scroll down so you can see the contours there. So this is like over 90%. So tropical storm force winds are over 39 miles per hour. And then hurricane force winds take over when you get to 74 miles per hour. And those are sustained. So we can go through the hurricane stuff here. So this is now, obviously, we'll loop this here. Because it's a tropical storm right now becoming a hurricane, that's why when you loop it, there's nothing, then you can see these probabilities increase. But you can see their south central coast of Louisiana is 50 to 60% chances of getting hurricane force winds, probability-wise, as this storm moves northward. And these probabilities gives you the area with the highest confidence of impact. But the reason they're spread is because the models, as they go out in time, it's kind of like you're adding up a bunch of numbers, 10 plus 20 plus 25. But when you make a mistake, everything that you kind of do after that is going to have some degree of error. So that's why forecasts tend to become less accurate as you go out in time. So that really accounts for that spread there. And there's a lot of good stuff on this web page. Storm surge, that's really important for folks along the coast. I mean, you can get a 20, 30-foot storm surge with some of these big storms. And we've kind of so there's this watch warning cone that kind of shows where the storm's most likely going to track. And as I mentioned, its area increases as you go out in time because of the uncertainty on the track. But you can kind of tend to see where the center of the storm is most likely to go. Now, it often falls outside even this box here. And a lot of what we tell our emergency managers, those folks that have to make the decisions, is to focus on the individual impacts, because it doesn't necessarily matter where the storm tracks. It's the impact to the area that it does. So, example, I don't know if people remember Tropical Storm Irene, 2011. So that storm brought us, we had like 50, 60 mile an hour wind gusts in New England. We had power outages and that. So we were actually closer to the track, but further away, up in northern New England, Vermont, New Hampshire, they didn't get the wind, but they had it much worse because they had 6 to 10 inches of rainfall over a very short time, and they had horrific flash flooding, roads washed out. So that's why it's important to kind of focus on the individual hazard that, flash flooding, storm surge, wind strength, and putting it all together. And that's what the emergency managers are really focused on. So flash flooding potential. Again, this gives the highest probability down into from Louisiana into southern Mississippi, and you can see it's kind of spreading into Alabama. Now, if the storm ends up going a little further east, then this will shift further east. If it ends up going further west, then this would shift further west. So, a lot of what we do with forecasts now, there's a lot of talk about probabilistic. The forecast is always, how much snow are we going to get? 5.2 inches. Well, we're not that good. There's uncertainty. You don't know where the rain-snow line is exactly going to set up. So what is the probability? So what is the probability of getting over 4 inches of snow, or the probability of getting over 8 inches of snow? And we're still obviously giving our most likely outcome, but we're getting into areas now where we're giving, especially our high-end users, like DOT, those folks that need to know to clean the roads, what our confidence level is. So we may have a scenario where it looks like we're getting, 6 to 12 inches of snow, but what's the low end? What's the high end? What if the rain-snow line ends up further west? Well, we could only get 2 inches, but what if it ends up further east and we end up more snow? We could get 15 or 16 inches. And, we're not the decision makers. We just provide the information. And then, the emergency managers, school superintendents, governors, they decide based on the information that we're providing them what the course of action is going to be. And, a lot of it, when the Weather Service, and I had in the other part of my presentation, we were talking about decision support services. That's where our jobs really changed over the past 5 to 10 years, is that we are now doing more briefings to these folks, giving them the information they need, and we're learning from them as well. So if you see a map of snowfall, everyone remember the blizzard of 2013, February? There was 2 to 3 feet of snow in a lot of places. So if we put up a snowfall map and we had 2 to 3 feet of snow, from central Mass into northeast Mass, and then in, say, Plymouth County, we only had 12 to 18 inches. So the first thought is, well, where do we want to send, if I'm DOT, where do I want to send most of my equipment? Obviously, we're going to need it everywhere, but more where there's going to be 2 to 3 feet, or where there's going to be 10 to 18 inches, more where there's going to be 2 to 3 feet is what you'd initially think. But in this case, the snow is going to be wet. It's going to cause a lot of damage. So where everyone recovered from that blizzard, in a couple days, parts of Plymouth County, where they also had strong winds combined with the wet snow, just had tremendous tree damage and tremendous power outages that lasted weeks. So us being able to give that type of information to them, is it going to be a wet snow? Because if you get 8 inches of snow and it's dry, it's not going to cause a problem other than, the roads, obviously, which can be treated. But if you get 8 inches of wet snow, especially if you get it early in the season when there's still leaves on the trees, like the Halloween storm we had back in 2011, it was mainly rain here, but if you got into interior Massachusetts, they had 12 to 20 inches of snow before Halloween, and people were without power for 3 to 4 weeks. So that's the type of information that they need to know. And a lot of what we've learned too is that these decision makers, they understand that we're not perfect and we're not going to get the exact forecast numbers. But a lot of times timing and impacts are much more important, because if we're expecting 6 to 12 inches of snow on a Sunday morning, well, that's not great. But it's Sunday, a lot of people aren't working, so they may not be as concerned about it. But if you get 3 to 4 inches of snow at 5 p.m. on a Wednesday, with the traffic we have now, and if it's snowing hard, it's going to cause a big problem. So timing, when's it going to start, when's it going to stop, how much, is it a wet, dry snow, is it going to be accompanied with wind, where it cause damage, those type of things are key. So anyone have any questions? Yeah.
I wanted to ask about barometric pressure.
Yeah.
I have one of those things that's called a four-man's barometer. It's this glass container with some liquid in it, and I guess when the barometric pressure goes down, it forces the liquid up like a little spout, and that's supposed to be an indication that bad weather is coming. What exactly is the barometric pressure?
So basically, when you have high pressure overhead, the barometric pressure rises. You get more, the air tends to be more dense, so there's more weight to it in that sense. So the pressure tends to be higher. When you have low pressure, the barometer tends to be lower, and that is a potential indication of rain or snow. Now, it doesn't always work that way, because you can have a high pressure system moving from, say, Quebec into northern New England, and your pressure's rising, but you have warm air coming up over it, so you get overrunning snow. So it's not like a one-to-one relationship, but in general, when you have the higher pressure means generally dry weather, and when the pressure's falling, it means stormy weather. Now, when the pressure's rising or falling rapidly over a short time period, there's usually some type of big front, some type of big storm system in there, if that makes sense. So any other questions? Yeah.
When we were talking about thunderstorms, could you tell me what the difference between a nor'easter and a thunderstorm is?
Yeah, so a nor'easter those are tend of what we think of in the, they don't have to be in the wintertime, but the idea is low pressure develops off the coast. Now it could develop down in Florida, it can develop off the Atlantic coast, but the key is that with a nor'easter, the low pressure system is going to track to our east. And when a low pressure system tracks to your east, in the northern hemisphere, low pressure winds blow counterclockwise around low pressure. So if I can show you here, let's pull up a map here. So imagine we got the map of the United States. We have a low pressure system developing off Cape Hatteras. It's moving like this. Okay, so in the northern hemisphere, winds blow counterclockwise. So if the low's here, that's going to bring a north wind here. Now, if you have a high over Quebec, that's going to push the cold air down. So that's usually a big setup for a snowstorm. If you take the storm and bring it to your west, those are called inland runners. Well, if you think about that, if you have a storm going up over Albany and you have counterclockwise winds around low pressure, well, the wind's going to come from the south. That's a warmer direction. So that can be snow to rain. Obviously, the matters depends on what the atmosphere is like when you start. Is it cold initially? Is it cold enough for snow? I mean, you can get a nor'easter and it's just too warm, so it just rains. But when we think of the term nor'easter, the winds are going to be from the northeast. Now, in terms of like thunderstorms, usually you don't even need like a big low pressure system to spawn that. In the summertime, if it's like 85, 90 degrees, and it's really humid, like the dew point 70, and you have a cold front coming, that can really trigger those thunderstorms because you have that cold air undercutting the warm air, it's forcing it up, it's rising, it's cooling, condensing, and then you get the rain. It's kind of, if you're like boiling a pot of water and you see that steam rising up, it's rising up because it's rising into a cooler environment. So it lifts up. It basically is the same type of mechanism, if that makes sense.
So if I have it correct in my head, isn't there one side of a storm that has more rain and the other side has more wind?
Yeah. So with tropical systems, what tends to happen is in the south they're more symmetrical. You usually still get the strongest winds on the east side of it and the heaviest rain on the west side of it. Usually once they get up, into the mid-Atlantic and then into New England especially, that's where it takes on, real significant lopsided structure where the heavy rain and flooding is left of track. So when you think left of track, so if you get a hurricane going up here, or tropical system going up here, your heavy rain's out here, your wind is east. Wind, storm surge is east. So if you look at tracks like Irene, various scenarios that brought flooding, it's usually depending on the track. A tropical system passing to our east, you could still get wind, but normally it's the rain and flash flooding that's going to be the big issue, because they tend to become more lopsided. Now there's exceptions. Hurricane Carol, if you heard of that one, back in the 50s, might have been early 60s actually. That storm was probably the most tropical system we've ever had in New England. It was very, very symmetrical. So, but they tend to be lopsided where there's not much wind on the west side. So you could be, That's why when you see those tracks, here's where the track of the hurricane's going. That doesn't necessarily tell you, because if you could be 50 miles west of the track, and you could be 150 miles east of the track. You may get stronger winds 150 miles east of the track, but you may get the flooding, 50 miles west of it. So that's why there's discussion on how we present this information. When we show, a track and you see the different areas in that where we're expecting it, everyone's focused on that main line, but it's really the impacts that end up, obviously causing the issues.
So more or less, unless it's out towards sea more, the coastline's gonna get the wind typically.
Yeah, I mean, the coast is always more subject to wind. You'll notice if you go to when you go to the Cape and Islands, and the trees there, they don't tend to grow as tall. Nature knows that it really can't take all the wind that they tend to get. And one of the reasons is friction. You have a lot more friction over land than over the ocean. So when winds are blowing from the east, really they're coming unabated across the ocean, where there's not as much friction, so you can get really, really strong winds. As you get further inland, that's harder to come by. Usually the Earth's always trying to stay in balance, so that's why we have storms. The difference between low and high pressure, so if you have like a really, really strong high up here and a really, really strong low here, and that's where we call it tight isobars, that's ideal for big wind. So it's really, you can have a really strong low pressure system and you still get wind, but you can also have a weaker low pressure system, but a very strong high nearby. And it's the difference in pressure that's causing the wind. So you can actually have, more wind with a weaker low if you have a strong high pressure, say north of the area, if that makes sense. So one of the things we could do, kind of look at some of the tropical headlines that they have out here before we end up. So again, this is, I went to the local office down in New Orleans here. So this is the system, this is the expected track. Again, this is the cone. Usually, eventually 2 out of 3 times it actually will come outside the cone eventually. That's why we tell people not to focus on it. And again, we talked about how it doesn't necessarily reflect the impacts. So that's where you really have to read the individual products. So we can see, we could go down here and I'll click on area there down in southern Louisiana, and we can kind of go through the forecast here, what they're calling for. Have to get a view here. So you could see right now, tropical storm conditions expected, hurricane conditions possible. This is just Wednesday, new rainfall between 2 and 3 inches, new rainfall between 1/10 and 1/4 of an inch. So they're really forecasting this to be tomorrow, where the heaviest rain falls. And then they're mentioning hurricane conditions possible. So basically, they haven't put in a wind speed yet, but they probably will in the next 12 to 24 hours. So that's where you'll see, they may have like 70 to 80 mile an hour gusts, depending on how strong the storm is. But you can read the various products here. So there's obviously a lot of headlines. So we'll go to this one. This is like the storm surge. So this will give you, the expected impacts and you can kind of read through there what they're expecting, the amount of storm surge, and then you can click on this link here. So this is the flood watch. This is the heavy rain and flash flooding. They're just obviously talking about excessive rainfall, flooding of rivers, streams, roads, low-lying areas. So the normal situation is, I mentioned at the beginning, we usually have 2 people on shift at least. But when you have a scenario like this, it's basically all hands on deck. So, you switch to work 12-hour shifts. There's usually 3-4 extra people working with you as well, just, because someone's doing the forecast, someone's got to answer the phone, do media interviews, talk with emergency managers. They may have very specific questions for their area in terms of, coastal flooding or wind damage, or a river may be going out of its banks. How high do you expect it to go? Those type of things. But yeah, there's definitely a lot of products that you have during these tropical systems. So anything else? Yeah.
Is the storm surge predictions, are those relatively accurate typically in our
So the storm surge predictions are really key on the exact track of the storm. Because, for example, if the storm goes 25 miles west or east, if it goes to just to your west or just to your east, that's going to make a big difference because hurricane, it's basically a very strong low pressure system. So winds are going counterclockwise. So if it's passing to your west, you're getting southerly winds. So there's something called a 10% exceedance threshold. And what that is most of our forecasts, when we give a winter storm or, here's what we're expecting, 8 to 16 inches. We may give mention there's a low risk for this or whatever, but when we're talking about a tropical system, it can be life-threatening. So if there's a 10% chance, that's going to be the forecast. So it's kind of like the reasonable worst case scenario, and emergency managers understand that because you can't take the risk. A lot of times you'll see on the maps there, I kind of lost my cursor here, but where you're on the exact maps, you'll see the conditions vary depending on the specific location that you're at, if that makes sense. But with tropical systems, because the risk is so high, if it goes 25 miles further west or east, it's not a huge difference in our viewpoint, but in exactly what it's going to do, because you're having south winds coming, say right up the ocean on the south coast. That may make the difference between a 10 to 15 foot storm surge and a 2 to 3 foot storm surge. And also, what really controls the amount of storm surge and coastal flooding is the time. Does it occur during high tide or low tide? So the 38 hurricane, are you familiar with that one? Yeah, that was called the Long Island Express. And that occurred during high tide, and that's why it was so devastating. We had 15-foot storm surge up like Narragansett Bay, and people weren't expecting it because the storm, it was interesting how things were, done, obviously, without satellite. And, they knew there was a really strong hurricane out there from ship observations. And initially, it was supposed to hit Florida, and it didn't. And then it didn't really, it looked like they thought it was going to go out to sea, because they normally do. Because the prevailing winds are from the west to east. So usually as they come up, they get knocked eastward, thankfully. But in this case, there was a front coming down across the Great Lakes, and what we call an upper trough, which means the winds in the upper levels of the atmosphere were actually coming from the south, and it forced it right up. And basically the storm went from like being east of Cape Hatteras, where North Carolina didn't really have much impacts from this. So no one did until it came, towards, Long Island and went up southern New England. And it was, completely unexpected. It was moving like 50 to 60 miles an hour. So it was all of a sudden, 150 mile an hour wind gusts, because it was being, accelerated by that jet to the south, and it just surged right up northward. So it seems like we get, if you look back to historical records, there was a similar storm to the 1938 hurricane in 1815. And that really took down, you're welcome, many trees in central Massachusetts. It looked like tornado damage. It took, obviously, decades for them to grow back. And then there was, just from research, they think the biggest hurricane ever was in 1635 in New England. And they actually know the track of it because of the wind direction. Because areas like in Boston, I mean, it was bad. They got a lot of wind. But all of a sudden, as you got down towards past the South Shore, there was massive coastal flooding. And because the wind, was from the south and east, where it was on the backside, it was from the west. But yeah, it's amazing, like just from journal, putting it all together, they can come up with, a likely track of it.
They have an estimated wind speed? I mean, you can't, right?
Yeah, I mean, it's hard to, I mean, most likely it was like probably a high-end Cat 3. That they called it the Great Colonial Hurricane of 1635. So
You're saying that's the biggest?
Whatever we considered like the last 500 years, it obviously going back beyond that, it's amazing to even go back to that. But it's, if you look at the frequency, there's other hurricanes. I mean, the 30s, 40s, and 50s were extremely active here. I mean, we had Carol and Edna within 10 days of each other, and we haven't, like I said, we haven't had a hurricane. We've had tropical systems make landfall, but not a bona fide hurricane since Bob in the early 90s. So we're definitely overdue. And that's why we get out and we do a lot of presentations, especially to those folks on the coast, because it's generations that haven't really experienced it. And something when you haven't experienced it, it's hard to know what your reaction to it would be, what people's reaction would be. Would people evacuate, or would they say, "No, I've lived here, all my life. There's never been anything like it." So, and that goes back to that 10% exceedance threshold. When you see those hurricane watches and warnings, they're spread out over a large area. Not everyone in there is going to get those hurricane force winds, but you have to warn a very large area because we don't know the exact track. Sometimes the worst of the winds could be within 30, 40 miles of the hurricane. There's still, wind out away from it, but when the damage increases exponentially as the wind speeds increase. So when you go from, it's not like a so when you go from 50 to 60, and then you go from 60 to 70, 60 to 70 is much worse. And then 70 to 80 is worse than that. So it's kind of an exponential increase.
So a lot of these systems seem to peter out like Nova Scotia-ish. I mean, how far up do they go? It seems amazing they can have that kind of strength in that.
Yeah, so they tend to, and there's debate in the meteorology community how they want to be classified, because they go right into the Canadian Maritimes. Actually, they have a higher frequency of being hit by hurricanes than we do because they stick out. Now, are they truly tropical or extratropical or both? I know that gets debated in the meteorology community, but to most people, it's the amount of damage. So whether it's part tropical, part extratropical, which would be more characteristic of our, winter storms, it doesn't really matter if it's, bringing 70, 80, 90 mile an hour winds, the damage is still going to be the same. And a lot of times, the wind fields spread out as you get into New England, where in the South, they may be really more localized. There was one, obviously Camille, back in the late 60s. That was a very small hurricane, but it was devastating for a very small area. And you get other storms where the wind fields are more spread out. And that obviously impacts storm surge, the size of it. So it's not always like category 1 does this, category 2 does this, category. To an extent, yeah, that's true. As you go up in categories, the damage is going to be worse, but the size of the storm, the intensity, how quickly it's moving. So, and any other questions? Well, great, thank you. I'm glad we were able to. When I had the little glitch, it was kind of good because I was able to show you, some of our websites and just various information that's available. And if you have any questions, you feel free to email me. It's just hayden.frank@noaa.gov. So thank you, everyone.